Okay, problem number 14. All right, they tell me that I have a vector they label D, and they said D is 31 degrees off the positive y-axis. So that means if this is the positive y-axis, it means I come this way 31 degrees. This is D, and it equals 6. Okay. Now what am I asked to do? I'm asked to find the x and the y components. So I can go ahead and draw them in right now. This is my x. I'll label it dx. And my dy, of course, would be right here over the top of the axis. I'm just not drawing it on top of my axis, like that. Okay, let's redraw the triangle over here a little bigger because it's a little easier to see. So my triangle looks like this. I have dy, and I have dx, and d equals 6, and this angle is 31 degrees. Okay, so just like we knew on the previous page, by definition, cosine of an angle is adjacent over hypotenuse, and sine of an angle is opposite over hypotenuse. So again, you can rearrange that, but let's go ahead and substitute in. I'm looking for dx and dy. So cosine of 31 degrees equals adjacent. The adjacent one is dy over hypotenuse, which is d. Sine of theta opposite is dx. Hypotenuse is d. Let's rearrange to solve for dx and dy. Okay, so there's the two formulas. These are the same formulas that were derived in the chapter, but in case you forget how we got there, it's just based on the basic definition of sine and cosine. Now I can substitute in my value of d, which is 6. And solve for my two numbers. And what do you get? You get 6 times cosine of 31, 5.14. 6 times sine of 31 equals 3.1. But now, I'm not exactly done here, am I? What do I need to consider? I need to consider the sine. All I have done here is calculate the magnitude. I need to be very careful to make sure that I'm giving the correct direction. Unless they ask for magnitude. If you're asking for magnitude, then you give absolute value. But if they're asking for the components, I have to consider direction because a vector has both magnitude and direction. So let's come up and look. dy is pointing in the vertical direction, so it's going to be positive. So my dy will equal 5.14 meters per second. Oh, this is a distance. Sorry. And it's in kilometers. Okay. D, wow, did I really do that? That was supposed to be dx. You guys didn't say anything. Maybe you did. I probably just didn't hear you. That's supposed to be dx. Okay, so dx is going to equal, which way is dx pointing? It is pointing to the left. That means it is negative. So this is going to be minus 3.1 kilometers. Now, is there a way that I could do the same problem without having to stop and think about the direction in the end? Because I want to make sure that I get my sign correct. remember that the angles are defined by convention from 0 all the way over to here. So when in this problem, when they said that the vector is 31 degrees off of vertical, what they could have also said was that it is 121 degrees off of vertical. If otherwise, if they just said 31 degrees, I might draw it here. Okay, so you got to be very careful about the angle that you use and how you define it. We'll talk about that a little bit on some of the upcoming problems. But there's the answer for this problem.